Hey guys, in this video, I'm gonna go over some notes and some differences between ionic and covalent bonds. So let's go ahead and get started. First of all, on your graphic organizer, this Venn diagram, let me show you how to take notes, and then we'll get into what the differences are. So what you're seeing in front of you is little graphic organizer, ionic versus covalent bonds. And so these are just drawings. So Google Docs does a really cool feature called drawings. It's kind of like shapes from Microsoft Word, but you can enter text in here so it will look more like your Venn diagrams that you're used to. So here's how you do that. If you click, you can double click on the circle, or you can click edit, either one. It's going to pull up the editing box and you'll see that picture on here. The next thing you'll want to do is add in a text box because we want to add text, and you'll have to draw in the text box here. Okay, so I'd probably make it about that large. You don't want to go too far over because then you'll be cutting into the similarities section on your Venn diagram. So probably about here. And then we are going to bullet point these differences. And so to get a bullet, you'll just click on these little dots up at the top, and then you've got your bullet. So while we already have this open, I'll go ahead and give you the first piece. This is for ionic bonds. Ionic bonds occur between a metal and a non-metal. So we'll just write occurs between a metal and a non-metal. And let me go back to my teacher copy of this, and I'm going to see a couple things really fast. So I'm going to check on my font size. So I have my font size set to 14. I changed the shape of my oval a little bit too, and you're more than welcome if you need to do that. You can change this shape up a little bit if you need to make it larger, smaller, whatever's going to work best for you to get all of your notes down. Okay, and then if you hit enter, you'll get your second bullet, and you can continue on through that. Let's see. Something else you probably need to see how to do. Over here on the covalent side, we're going to have some sub-bullets, and then we're also going to have some subscripts, so like H2O. So let me go ahead and show you that really fast. Again, that'll be on the covalent side, but I'll go ahead and show you on this side. So to get a sub-bullet, you're going to enter down so that you have like a regular filled in bullet. And then if you just hit the tab button on your computer keyboard, that'll kind of indent that bullet over. And then let's say you wanted to write the formula for water, H2O. You have a subscript of 2, meaning that you've got 2 hydrogens to 1 oxygen. And I'm going to show you really fast how to get that little subscript. So go ahead and write your capital H. Okay. There's probably a way to do it up here. But the fastest and easiest way that I know how to do it is a keyboard shortcut, and that is Control and comma on your keyboard. So if you hold those two things down at the same time, so Control and comma, notice that my cursor goes super tiny. So we want to go ahead and enter the 2, and then Control comma again will bring it back to like its regular size. So it'll take you out of the subscript. And then your oxygen is a capital O. All right. So I'm going to delete that off of mine because you don't need that on there. If you hit save and close, you can see that it will update on your Google Doc. And I changed the size of my oval there. So then I'll need to probably go change the size of this guy. You can also like change the actual size of what's showing up there. That's probably what I would do with this one. And then change him so that they're still overlapping. Okay, so let's go ahead and move on now to what are the differences between ionic and covalent bonds. So ionic and covalent bonds are 2 of 3 types of chemical bonds that occur that hold stuff together. Okay, and that stuff is what makes up our everyday lives and allows us to do lots of different things, right? Like, for example, it creates the gasoline that we need to fuel our cars, to fuel airplanes and rockets. It makes up the foods that we eat. It makes up I mean, just a number of different things, the materials, the clothing that you're wearing. So again, all of these things in our everyday lives are made up of substances. Those substances are held together by something called a chemical bond. So there are 3 different types of chemical bonds. In our class, we're really just going to focus on 2 of them, and those are ionic and covalent bonds. Okay, so let me zoom in here really fast. This is my teacher copy, and so you guys will need to take your notes down from the graphic organizer as I'm discussing those with you. So as we already said, for ionic, it occurs between a metal and a non-metal. So how you know if an atom or a compound, is an ionic compound is, well, we're going to need to go to our periodic table. So pull up your ptable.com, and these are already sorted for you. You have your metals and your non-metals over here in the green, and then your metalloids are those on this little staircase. So I like to highlight this metalloids because then you can see everything to the left of the metalloids is going to be a metal. Everything to the right is going to be a non-metal. So if you have a compound that is made up of one or more things on the left, one or more things on the right, that is an ionic compound. Okay? All right. Next thing is that, so we've been talking the last couple of days about valence electrons, those electrons in the outside shell of your atom. And this compound is held together by valence electrons being donated or gained from one thing to the next. So going back to P table, your metal that's on the left side is typically going to donate those electrons to the non-metal. Okay, so they're going to donate electrons. Metals are going to gain electrons. All right, this is all because that outside shell or valence electrons either wants to be completely full at 8 or completely empty at 0. That's just a rule of all of our atoms. They either want to have a completely full outer shell of 8, completely empty shell 0. Either one. All right. Moving on. This third bullet, the electronegativity of an ionic compound is greater than 1.7. First of all, let's talk about electronegativity. Electronegativity is a property that, it's a chemical property, and it has to do with an atom's desire or an atom's pull for electrons. Okay, so we talked about how you either want to have 8 in your outside shell or you want to have 0, right? So the higher electronegativity value that you have, the stronger pull or the more you want those electrons. Okay, so from P table, I just went up here to properties and then I clicked on electronegativity. So electronegativity is on a scale, and we've talked about this in class a little bit. We've talked about, I know this was also one of the trends that you guys looked at where we had to graph the electronegativity values as it was increasing as you went across the periodic table. So the scale for electronegativity is 0 to 4. So if your electronegativity is a 0, well, you don't want electrons. You don't have a very strong pull. You want to get rid of them. So you're going to want to have that outside shell be 0 electrons. If your electronegativity is lower, you do not have a strong pull for electrons. You want 0 in the outside shell. Now, if your electronegativity is closer to 4, then you have a really strong pull for electrons and you really want to gain those. Okay, so just looking at our periodic table, we can look over here at our metals and we see that their electronegativities are listed underneath of them. So for lithium, it's that 0.98. We can keep going down. Francium, 0.7. So it's like decreasing as we go down. And then we can go across and we notice that, okay, so for potassium, it's 0.82, calcium is 1, scandium 136, 154, 163. So it's increasing. Most of the time it's increasing as we are working our way across. And then we get over here to these non-metals and we really see a jump. So like bromine is 2.96. So again, the scale is 0 to 4. bromine really wants electrons. Okay, our highest and most electronegative is fluorine. And so it has the strongest electronegativity of all of the atoms. If you're combining with fluorine, you're donating your electrons because he's going to steal them. He really wants to get to 8 electrons on the outside shell, and he's already at 7 because he's in this group 7. And so he just wants one more to get to 8, so he has a really strong pull. You can kind of think of it like a tug of war, right? So like electronegativity is a pull or desire or strength for electrons. So if you have a high electronegativity, you have a really strong pull and you're going to win that tug of war. Okay. Now for ionic compounds, okay, our electronegativity difference is a 1.7. So what that means, an example, you can go ahead and write the example. It's NaCl. So let's look at those two. We've got sodium that is a 0.93. I'm going to pull up my calculator really fast. And then over here at chlorine, we've got 316. All right, so 3.16 on our chlorine. And then we're going to take the difference between that, between chlorine and sodium's was 0.93. And we get 223 as its difference, which is greater than 1.7. Therefore, this is an ionic bond. All right. So let's move on and talk a little bit about covalent bonds. So covalent is made up of 2 nonmetals. So going back to P table, here's my metalloids in the green staircase, and everything to the right of the staircase are nonmetals. So if you had like CO2 or O2, oxygen that you breathe in, right? If you had, one more thing, hydrogen is also a nonmetal. Okay, so I said everything to the right is a nonmetal and hydrogen. Okay, don't forget about him. Some people think that, it's a metal because it's over here on this side, but it is a nonmetal. Okay, so covalent bonds exist between 2 nonmetals. In this case, valence electrons are shared between atoms, and they're shared in order to get to a total of 8 valence electrons. Whereas in ionic, the electrons were either donated or gained. Okay, now that sharing can be equal or unequal. All right, and it just depends on those electronegativity values. So when those electrons are shared unequally, it results in something called a polar covalent bond. And this is when your electronegativity differences are between 0.5 and 1.7. So let's look at H2O. Let's look at water together. And I'll get up my calculator here again. So oxygen has I gotta get electronegativities as well. There we go. Oxygen has a 3.44 electronegativity, whereas hydrogen is 2.20. So when you subtract those, we get electronegativity of 1.24, okay? So again, that is in that range of 0.5 to 1.7. Therefore, water is a polar covalent bond, all right? The other option is a nonpolar covalent bond, which means its electronegativity is between 0. The difference is between 0 and 0.5. So our example there is carbon dioxide. We'll pull those values up and see some little calculations here. Let's see. So oxygen is 344 and carbon is 255. So 3.44 minus 2.55 gives us a difference of 0.89, which again is in that little range. Okay. So I'm going to go ahead and stop the recording here. If you are still needing a little bit, forgot to talk about what's in the middle. The thing that's similar between both bonds is that, the whole purpose, and this goes back to the beginning of my video, the whole purpose is that they hold these atoms together and make up everything in our universe, okay? And then if you need any more help with that, I will post this link to Mr. Bozeman's science. He goes through pretty much the same thing that I've went through with you guys, but he might do a little better job than me. So if you need any more help, go check him out.